What's up, guys? Today we're going to be solving Leetcode question 987, vertical order traversal of a binary tree. This is a popular interview question, and yeah, let's get to it. So, if you've followed the solution on Geeks for Geeks, that does not really solve the problem on Leetcode because it does not it print. So the question is, you have to print all the nodes that are in the same vertical line. The problem with the solution on Geeks for Geeks is it does not respect the order within the vertical line. Meaning, if two nodes belong to the same vertical line, um, the order in which they will be added to the resulting array is not in our hands if you follow that solution. Anyway, I shouldn't talk about a solution that I'm not presenting, but when I solved this problem, I was wondering why it wasn't working, and then I understood that LeetCode wanted us to maintain the order of the nodes in the vertical line, meaning if two nodes are on the same vertical line, and if one node appears higher in the um, tree than another node, then it should be added first in its element in its array in the resulting array. Anyway, coming to the explanation of the solution for this problem, um, the solution of this problem is based on the concept of horizontal distances. What that means is if we map our binary tree to a coordinate system, now that sounds very fancy, but it's really just assume that your root is at x equal to 0, y equal to 0. Now every node to the left of this, as you go towards the left of this root, the x coordinate will keep decreasing by 1, meaning the left child of the root will, the x coordinate of the left child of the root will be -1. The x coordinate of the left child of that node will be -2, and so on. And then the same way the x coordinate will increase towards the right, like the right child of the root will be +1, the x coordinate of the right child of the root will be +1, the right child of that will have an x coordinate of +2, and um, for the y coordinate, the y will increase downwards positively. So what that means is, so basically what we'll do is we'll label all our nodes. We'll give coordinates to all our nodes of the binary tree. Now, this question, now that we have given x and y coordinates to all our nodes, the problem boils down to um, a problem. So basically, if you sort, now you have a locations array, assume, uh, with all the x and y coordinates of all the nodes in the binary tree. Now, if you sort this locations array by x, what that means is all the nodes which belong to the same vertical line will come together, right? Meaning, and if we are sorting by x, uh, the in ascending order of x, supposing all nodes which have -2 x coordinate will be at the beginning of the array, then -1, then 0, then 1, 2, 3, however it goes. So we'll have all nodes of the same vertical line together, and they'll be in proper increasing order. But again, we run into the problem that it does not maintain the y order within the group of elements which have the same x coordinate. So what we have to do is we have to first sort by x and then sort the same array by y, so that um, a group of nodes which have the same x coordinate are now sorted within themselves by their y coordinate. Meaning, so now so if there are 5 nodes which have um, x coordinate as -1, and then we sort them by their y coordinates. um, what that essentially does is it will sort the nodes in x and y coordinates of -1, 1, -1, 2, -1, 3, so on and so forth. And so after we have sorted the locations array in that manner, it basically the problem is done. Like we just have to construct a result array and return that result array. You'll understand the solution better as I code. So I'm just going to begin coding. We don't really need more explanation than that. You'll understand better as I code the problem. Okay. So I'm going to use a struct, or if you're not familiar with struct, it's simply a, you can imagine it as a class. I'll create a new location struct. We'll give it an x coordinate, a y coordinate, and the value. Just adding the constructor here. The value is the value of the node, the y coordinate, and the value. Some boilerplate. I'm sorry. Cool, that's done. Um, Now, so we also have to label the nodes, right? So I'll write that routine first so that we can then get to the meat of the problem. Like we don't have to stop. I don't have to stop while writing the main crux of the problem. So it's basically a DFS. Just to make it verbose, I'll write it as find all locations. Oh, come on. Okay. Okay. So what will this need? This will need the node. This will be a traversal routine. It will need the current x coordinate, the current y coordinate, and a locations array that we'll populate. Ignore the inout, it's just a way of passing by reference in Swift. You can ignore that. Okay. Just putting in an empty a nil check. So I'm appending the current node in the locations array. What all do I need? I need the x, the y, and the value, right? So tree node dot val. Okay, and now just so tree node dot left, comma. So the left no, if I go left, the x coordinate decreases by one. That is what I've done here, and since I'm going down, like I'm traversing down the tree, the y coordinate will just keep on increasing. Just passing the locations array by reference. Now doing the same for the right child. The x coordinate increases towards the right, but the y coordinate will keep on decreasing as we go down the tree. That's it. So we are done with the construction of the locations array. Now I'll get to the main vertical traversal routine. Putting it in a null check here. The root shouldn't be null, else return an empty array. Okay. Create a locations, an empty location array. Populate it. So I'll pass the root. The x coordinate of the root is 0, the y coordinate is also 0, and I'll pass locations. Cool. So at this point, locations is populated. Now comes the sorting part. This is the main part of this problem. So locations not sorted. This is just a closure syntax for sorting an array in Swift. Cool. So here I'm going to specify how we are going to sort the locations array. Cool. So suppose we have this is just Swift's way of specifying how to compare two custom objects. Since this is not a primitive data type, this is a custom class, not class struct. So we have to specify in what way we are trying to compare the two custom objects. That is all I'm going to specify in this function. Rest of all is just closure syntax, some Swift specific syntax. Okay. So if their x coordinate is not equal, we simply sort them by x, right? So we want the location with the lower x coordinate to appear at the beginning of the array. That is all I'm specifying here. Log2.x. Else if, so this else if handles a case where the x coordinates are same, but if the x coordinate is same, the y coordinate will definitely not be the same. The You should realize, let's note this fact that no two nodes in the tree will ever have the same x and the y coordinates. If the x coordinate of two nodes is the same, their y coordinates will definitely be different. Log1 dot y is, I don't really need to put in this check, but I'll just put it. So if their x coordinates is same but their y coordinates is not, we sort them in order of increasing y coordinate, meaning 0 to, so the y coordinate of the root is 0, and the y coordinate will keep on increasing as we go down the tree. So that's what we want. Log 2 dot y. Else we can just return false. Actually it will never come to this false, but for the sake of it, I'll just sort it by value. It will never reach here because two nodes will never have the same x and y coordinates. Okay, at this point our locations array should be sorted. Now it's simply normal coding and mathematics to construct the result array. We'll have to keep a check on the previous x. We are indexing it directly because we are sure that we'll at least have one node in the tree. There's a nil check at the top. Current vertical line. So all nodes in the same vertical line will be stored in their own array, and the final result array is a 2D array of all these 1D arrays. Okay, this is the final result that we will return. So parsing the sorted locations array, if the x coordinate of the current location is equal to the previous x coordinate, we simply append to the current vertical line, right? So we'll append the value because that's what we require here. As you can see, we require the values. If the x coordinate has changed, it means we found a new vertical line. So we'll create a new we'll reinitialize the current vertical line and reassign previous x. And yeah, so let's reassign previous x. We'll append the current vertical line to the main result. Current vertical line. And we'll reinitialize the current line. Sorry, current vertical line. Cool, and I think we'll miss out on the last vertical line, so I'll append that at the end because our loop will exit before that. And that should be it. Let's just go through the code, check if I've missed anything. Looks fine, looks fine, looks fine. Cool, let's check. Okay, that worked. Cool. Not the fastest of solutions, but it works. It's an easy to under. It's a solution that's easy to understand. Yeah, that's it with this video. Good luck, guys. Good night. Bye. Stay safe. Bye.